Hi, welcome back to Missing Chemistry. This is acid and bases and pH lesson number 7. Alright, so we're going to work this problem. We're going to be using quite a bit of variations. So we're going to do a variation of this formula that's M of A, M of V of A equals M of B, V of B. We're going to call it M of 1, V of 1 equals M of 2, V of 2, which we can do. So it's no big deal. We're definitely going to be using this formula. And we're also going to be using this particular formula for the first couple lessons here. And now let's go ahead and let's do this. An acidic solution has a pH of 4.0. If I dilute 10 milliliters of the solution to 1,000 milliliters, what is the pH? Okay, well, first of all, we have to look at a couple things here. Okay, so we know that 4, our pH of 4, okay, is the same as 1.0 times 10 to the negative 4. So 1.0 times 10 to the negative 4 M is a pH of 4.0. So now we're going to look at our concentrations. So we're going to take our M1 V1 equals M2 V2. Okay, so, and we're doing that because we're not using any bases, we're just going to use these as acids. So it makes better sense to change these A's, like, to 1, and these B's to 2. So this makes a whole lot more sense. So let's set up our players here. I call them players because it's easy to keep track of things. Alright, so what do we know? We know our original concentration is 1.0 times 10 to the negative 4. Okay. Our original volume was 10 milliliters, and our new volume is 1,000 milliliters. So we were looking for the new molarity. This guy right here. So we're going to isolate for M2. So M2 equals M1 V1 over V2. So let's go and plug in our numbers. M2 equals 1.0 times 10 to the negative 4 times 10 milliliters divided by our second volume, which is 1,000 milliliters. So our milliliters cancel out, and our M2 value, of course, is going to equal 1.0 times 10 to the negative 6 molarity. So now we want to know what is that new pH going to be. So we go pH equals the negative log of our hydrogen or our acid ions, because it's pH of 4, so it's an acid ion. So pH equals the negative log of 1.0 times 10 to the negative 6 M. So our pH is going to equal 6, and so it's still going to be an acid. Even though we diluted it a whole bunch, we went from a 4 to a 6, it's still an acid. Alright, so now let's look at our next problem. Okay, our next problem says the pH of a solution is 3.67. What is the OH concentration? Alright, so then what we do is we just simply say this. We have the pH, okay? So now we're going to go and do this. pH equals negative log of H3O plus. So we're going to go 3.67 equals the negative log of H3O plus, and we're going to do a variation of what we did on a problem earlier in another lesson. So we're going to make this log of H3O plus equals negative 3.67. So we're going to do the analog. Alright, so this will be anti-log of negative 3.67. And our new concentration is going to be our H3O. It's going to be 2.1 times 10 to the negative 4. Ha! Molarity. Pretty darn snarly, I have to say. Okay, last but not least, let's look at this last problem here. The last problem says, if a solution has an H concentration of 4.5 times 10 to the negative 7, molarity isn't an acid. Well, let's go ahead and determine that. Now, it's important to remember when we look at these two things here that H3O, hydrogen ion, is the same as the hydrogen ion. It's all the same. Just kind of, and we've been going in and out of that. I just want to let you know that it's all the same. So you have the concentration. So all you can do is go pH equals the negative log of our H ion, right? Our H ion was determined to be 4.5 times 10 to the negative 7 molarity. Okay? So then you go pH equals the negative log of 4.5 times 10 to the negative 7 m. Therefore, our pH is going to equal 6. No, not 6. Let me look here real quickly. Oh, well, it was pretty close. It's going to be actually 6.35. And that is definitely an acid because it's under 7. Well, that's it for this lesson, guys. You be snarly, and we'll see you back here at Musin Chemistry.